So welcome, we are going to discuss the related rates. Let's take the following problem as a motivation. So a spherical balloon is being inflated. So a spherical balloon, you have a spherical balloon and it's being inflated. So R is the radius of the balloon and it's increasing at the rate of 0.2 centimeter per second when R is 5. At what rate is the volume of the balloon increasing at the moment? So this is a sphere. The balloon is spherical, so the radius is R. Right. Now, what is given to us? So the radius of balloon is increasing at the rate of 0.2 centimeter per second. So you're given dr by dt is equals to 0.2 centimeter per second when r is 5. And then the question is, what is? So what do we want? We want dv. At what rate is the volume of the balloon increasing at that moment? So we want dv by dt, the rate of the increase in the volume, or change really, because here the volume is increasing, but rate of change in general, increase in the volume V with respect to time. So first we need to make a connection between V and R. So the volume of the sphere, because the balloon is spherical all the time, it's increasing in a spherical fashion as well. So you have dv by dt is 4 by 3 pi r cube. Now note that volume is also function of time and r is also function of time. So differentiate both sides. With respect to t, the time. In that case, we get what? dv by dt on one side. You have 4 by 3 pi, derivative of r cube is 3r square multiplied by dr by dt. Why is that? Because of the chain rule. So now what are the information given to us? So when r is 5, dr over dt is 0.2. So let's plug that in. We get therefore dv by dt is 4 by 3 times pi times 3. R is 5, so 5 square. dr by dt is 0.2. We can cancel a few things off. So 4 times 25 is 100. 100 times 0.2 is 20. 20 times pi, so 20 pi. And again, the units should be written properly. So what are the units? So the volume is increasing at 0.2 centimeter per second. So the length is measured in centimeters. So volume would be centimeter cube. Time is measured in second. So 20 pi centimeter cube per second. All right. So note that here we are employing the following. We want to find out dv by dt. So dv by dt is same as dv by dr times dr by dt. So dv by dr is what? So your v is 4 by 3 pi r cube. So derivative of that with respect to r is going to be 4 by 3 pi times 3r square, and dr by dt is, there's no expression of r in terms of t, so we'll just write dr by dt. Yeah, so this is what has happened here. So what is method of related rates? So you have two variables which are related by an equation, and both are function of third variable, usually time, right? Let's see, in this case, you have two variables, volume and radius. They are related to each other by this formula, V equals to 4 by 3 pi r cube. And they in turn, volume and radius both are function of time, right? Then we can find relation between their rates of change, right? By differentiating on both sides, you can, you see V and R are related, and they are both function of time, and you can take derivative on both sides with respect to t, you find a relation between their derivatives. So derivative is also rate of change, so hence the name related rates. So how do we proceed? We first identify an independent variable, usually time, on which the other quantities depend, and assign it as a symbol such as t. Also symbols to variable quantities that depend on t. So for example, here, if you go back to the older problem, here you had Vt is the volume at time t, and R of t should be radius at time t. Yeah, so we have basically gotten V and R both as a function of t, and then we find relation between them. Find equation that relates the dependent variables V and t. Have we done that here? Yes, we found out V is 4 by 3 pi r cube. Then what you do, you differentiate on both sides with respect to t and use chain rule if necessary. In this case, you see, we used derivative on both sides, and we use chain rule for this part here, right? For r cube, we use the chain rule, which was 3r squared dr by dt. And then last step is to substitute the information into related rate equation and solve for the unknown rate. So in this case, once you get to here, you knew the rate for dr by dt, you knew the rate dr by dt, so you know other values, substitute to find the unknown rate which you're looking for. What are we looking for here? dv by dt. So this is how the related rate problem proceeds. So let's look at another problem. A rocket is launched vertically and tracked by a radar station located on the ground 5 kilometers away from the launch pad. Suppose the angle elevation theta of line of sight to the rocket is increasing at 3 degrees per second when theta is 60. What is the velocity of the rocket at that instant? So first things first, let's draw a picture of this. So we have a rocket is launched vertically and tracked by a radar station located on the ground from the launch pad. So launch pad is somewhere here. So this is your launch pad. Let's say launch pad. And the rocket is already launched. The rocket is somewhere here. Okay. So rocket is here. Now, what is said? The distance from the radar station is located 5 kilometers away from the, so we have this distance between the launch pad and the radar station is 5 kilometers, and it's fixed, it's not changing. Now, what is an elevation angle? So the elevation angle is going to be the angle, if you are watching from here, how much do you have to look up? So the elevation angle is going to be theta. This is your elevation angle. So theta, let theta be the elevation angle. And what is given to us? D theta by dt is 3 degrees per second. What else is given to us when theta? So theta is 3 degree per second when theta equals to 60 degrees. What is asked? What is the velocity of the rocket? So let this be x. Then we are asking what is dx by dt, right? Because the change of the height would be giving you the velocity because the rocket is launched vertically, right? So all the change in the is in y direction, right? So I'm using the symbol x for it. You can use whatever symbol you want. So now we have basically, so we should say x is, since I've already drawn it here, x denotes the distance from the bottom of the, from the launch pad vertically up. Okay, so we want to find out what is dx by dt. Now we need to connect x, phi, and theta, right? Because the two variables are theta and x, so we need to make a connection between them. So as you can see, cosine theta is the one which will connect them. So cosine theta is going to be x by 5. Sorry, cosine theta is not going to be x by 5. We can't use cosine theta. Cosine theta is adjacent side upon hypotenuse. I meant tan theta. So tan theta is the one which will connect both of them. Sorry about that. So tan theta is opposite side upon adjacent side. So x over 5. This gives me x equals to 5 tan theta. Now note that we have to convert everything into radians. That is d theta by dt is, how do you convert degrees to radians? So you multiply by pi and divide by 180. When theta equals to 60 is same as pi by 3. So everything is measured in radians. We'll see briefly why do we need that. So take derivative with respect to x on both sides. So we get what? Dx by dt. Sorry, with respect to t. So we get derivative with respect to t on both sides. So 5 derivative of tan theta is secant square theta, then multiplied by d theta by dt. So we need to find out dx by dt. So what is given to us? So we have on one side, we have 5. Therefore, when theta equals to 60 degrees, dx by dt is going to be 5 secant square of pi by 3 times d theta by dt, which is 3 pi over 180, which is going to be 5 secant square pi by 6, pi by 3. So now cos of pi by 6 is, sorry, pi by 3 is 1 by 2. So secant is 1 over cos. So this is going to be 5 times 2 square times 3 pi by 180. So this is going to be 5 times, so 5 times 4, 20, 3 pi by 180. So 20 goes 3 pi by 3 pi, so 20 goes 9 times, so which is pi by 3. Again, what are the units of measurement? Units of measurement is, so units of measurement is going to be pi by 3. What is the x measured in? X is measured in, so the distance is measured in kilometers. So pi by 3 kilometer per what? Per what is the time measured in? Time is measured in seconds. So pi by 3 kilometer per second. So this is the answer. The reason to convert it into radians is the following. Note, if we have d by dx of sine x measured in degrees, this is going to be d by dx of sine, what is the degrees into radian? X pi by 180, and you get what? You get cos of x pi by 180 times derivative of inside, which is pi by 180. You have basically then cos of x degree times pi by 180. This is not same as cos x degree, right? There's a multiplication by pi by 180. So to avoid such conflicts, you can just write things in right away in radians. Okay. Now let's look at the next problem. So a 6 foot tall man walks with a speed of 8 feet per second away from the street light that is on top of 18 feet pole. How fast is the tip of the shadow moving when he's on the ground, when he's 10 feet from the light pole? So let's first draw this. So what are the statements? So what are the things given to us? A 6 foot tall walks with a speed of 8 feet per second away from the street light that is on top of 18 feet pole. So there is an 18 feet pole, and then there is a 6 foot tall, so this is 6 foot tall person walking away. Okay. So how fast is the tip of the shadow moving in the ground? So what is the tip of the shadow? So of course then you will have the shadow. So the light will fall on the person and it will basically generate a shadow. So this thing is 6. And the tip of the shadow is basically how fast is this x changing, right? Because the shadow tip is here and you have to basically see how fast is this point moving, right? And you need a fixed frame of reference for that. So let this be the fixed frame of reference. And what is given to us? The man is walking away from the street light 8 feet per second away. So if this is y, you are given dy by dt. Because he's going away, the y length is increasing. So it is 8 feet per second. Yeah. Now, one may ask the question, why not this length? Why is this length not why not we are taking this as a, for finding out the tip of the shadow? This is length of the shadow, not the tip of the shadow, all right? And suppose if the length of the shadow remains same moving ahead, then this change of this length of this green thing will not be, there'll be no change in it. So in that case, it will be 0, but the tip is still moving, right? So this is a setup. Now we need to relate these variables. We need to relate x, y, and hopefully 6 and 18, but x and y for sure to find out relation between them. Note that when I write x, it essentially means x of t, okay? Because they are all functions of time, right? They are changing with respect to time. So x is basically, let's write down everything. So, so let, so we need to, since I've drawn this, let's label them properly. So here I should have said x B, what x is the distance of tip of shadow from street light. Let y, so let x be this, also let y be what? The distance between the street light and the man. Yeah, so these kind of things must be quoted properly. Okay, so that's clear what they are. Now let's find out how to relate, basically how to make a relation between x, y, 18 and 6. So now for that, note that the triangle, this big triangle, is similar to this small triangle. Why is that? Because first of all, these angles are same, and then these angles are also same, right? So by angle uh, test for similarity, they are similar. So what does it mean? Means similar triangle have sides and similar triangles. So using similar triangles, what do we get? We get x over, so we get x, so this side over this side. So x over 18 is going to be, what is the small, for the small triangle, we have, this is going to be, the whole thing is x minus y over this side, which is 6. So from here we get x by 3 equals to x minus y. So this means y equals to x minus x by 3. This means y equals to 2x by 3. Now differentiating both sides, differentiating both sides with respect to t, the time, we get what? Dy by dt equals to 2 by 3 times dx by dt. So dy by dt is already given to you. You are looking for, so dx by dt is what you are looking for, right? So dx by dt was what we are looking for. So let's find that out. From this equation, you can see that this is going to be 8 equals to 2 by 3 times dx by dt. So this is going to be, when you multiply and divide on the other side, multiply by 3 and divide by 2, you will get dx by dt is 12 feet per second. Okay, so this means the tip of, therefore the tip of the shadow is moving at 12 feet per second rate. Okay, so that's the whole idea. So that information was not, but most of the times you will be using all the information given to you. So the light is, so this is a straight shoreline. So this is a shoreline. The nearest point P from the lighthouse, so this is your lighthouse. And this distance from the nearest point P is 3. And it's making basically 4 revolutions per minute. How fast is the beam of light moving along the shoreline? So we want to basically see the speed of light along the shoreline. So let that be basically, so at this, say, here is, say, beam of your light. Yeah. And so let's call this as y. So what is your y? Let y be the point on the shore where light is shining from point P at, so of course it's measured in kilometers because everything is given in kilometers here, 3 kilometers away, right? At time t. Okay. This angle is theta. Theta be the angle shown. So theta is the angle shown. Now you're given that theta, this angle, so light is making 4 revolutions per minute. That means d theta by dt is 4 revolution per minute, but that can be written as 4 times 2 pi because each revolution is 2 pi per minute, which is 8 pi per minute. Now, so that was a step 1. So draw a diagram. Step 2. Now we need to relate. So draw a diagram. That was step 1. Step 2, relate the variables, define the variables. And see what is given about them. Step 3 is relate these variables, right? So relate the variables. So what are the variables to relate? The variables to relate are y and theta, and maybe we can use 3. So what is the trigonometric ratio which connects them? Tan theta, which is y over 3, or this gives me 3 tan theta equals to y. Now differentiate with respect to, so now differentiate both sides with respect to time t. So now when we differentiate both sides with respect to time t, what do we get? We get dy by dt equals to 3 secant square theta d theta by dt. Right. Now what else is given to us? So we are asking when y is 1, right? It's saying how fast is the beam of light moving when it's 1 kilometer away from P? So we are asking the following question. We have d theta by dt is 8 pi and y equals to 1. So now from here, you can, so d theta by dt is 8 pi, y is 1, but we have no information about theta. So let's try to get an information about theta. And how do we get information about theta? So, okay, so okay. So now, what do we have? We have this side is y. This is, so for, if this is theta, we need to know what is this value, right? So y is 1. We already know this is 3, but we need to know this guy. That's how you'll find secant theta, right? Secant theta is hypotenuse upon adjacent side. So we need to find h. And for that, we'll use the Pythagoras theorem. So Pythagoras theorem tells me h equals to square root of 1 square plus 3 square, which is going to be square root of 10, right? This is Pythagoras theorem. So therefore we get, therefore dy by dt is going to be 3 times. Now what is secant theta? When y is 1, secant theta is square root of 10, hypotenuse divided by adjacent side, which is 3, the whole square, times d theta by dt, which is 8 pi. And this is measured in what? This is measured in kilometers per second. So let's simplify this. It's going to be 3 times 10 by 9 times 8, which is going to be 80 pi kilometer per, oh, sorry, this is measured in minutes, right? So 80 pi kilometer per minute. So this is your answer. So 80 pi by 3 kilometer per minute.